Good afternoon. This is Professor Todd Elliott, and this presentation will give you a bit of an overview and some critical details on, which is at the moment, lab experiment number 3 for logic for the Sump Pump system. Okay, so this is the problem, and this describes to us exactly what we're trying to design the circuit for. Okay, so please read this over. Don't just like, I'm just going to skip over this. No, this has a lot of the important information that you need to understand. Okay, so after lots of years in the field, I've figured out that one of the biggest challenges for me anyway is to be able to identify what the problem actually is, and what are we trying to accomplish, what are we trying to solve, what are we trying to do. And once you can rationalize that and clarify that in my mind exactly what we need to do, that makes it a lot easier to figure out how we're going to go about completing the task. Okay, so I will assume it's the same with you. So read through all this carefully, please. Make whatever little comments, notes that you need to. It explains what we're trying to do. But in essence, we have the shopping center. Occasionally, it floods due to heavy rains and too much groundwater. We have a sump. I assume you all know what a sump is. And in the sump, there's a pump motor and some level switches, probably float switches, and which are connected into some sort of controller, which we're going to have to design. And depending on the level of the water and the position of the switches, would determine whether the pump is running or not. Okay, so that's basically kind of it in a nutshell, but all the details are here. Okay, in addition, this page provides a summary of how each of the mechanical contacts are going to interact. Now, it's beyond the scope of our discussion today to discuss how we're going to actually interface, like a dry, open, contact to a logic circuit. Suffice it to say, it can be done. It's not a problem. So one of the things that we have to decide up front when you're sourcing your components is, for example, if you have a push button, when you depress the push button, do you want that to be interpreted by the control circuit as a logic 1 or logic 0? Or do you want it when it's open to be a 1 or 0? Like you have to decide, and there's no right or wrong answer, but that has to be defined, and that is what has been defined for us right here. Okay, for each of the inputs, and there's a total of 5 inputs, and they're all identified A, B, C, D, E. It indicates, is it active, is it 1 when closed, or a 0 when closed? Okay, we need to know that. So, for some of the problems, and we're going to be doing a lot more of these during class as we go forward, you go right from the description directly to the circuit. Some you might go from the description to the truth table to the circuit, and some you might go from the description to the logic equation to the circuit, and the latter case is what we're going to work with here. Okay, so we have our 3 statements. I'm going to just sort of highlight them as we go along. And so the 3 statements are, okay, it says the high level switch, let me highlighter go here. The high level switch is closed and the low level select is off. Okay, this is one of the conditions when the motor should run. Okay, so the high level switch, okay, that's going to be input B, and the low level select, that's a little bit confusing, is D. So that equation for that bit is B ANDed with D naught. Okay, we have B, because it's 1 when closed, when it's active, and when it's off, high select is going to give out a low, so that means we want D naught. Okay, so make sure you understand that. Okay, so I need another color highlighter. Let's go with green, light green. Okay, so that's one condition. The next condition says OR. It's going to be an OR gate. The low level switch is closed and the high level select is on. Okay, so we have the low level select and low level switch, sorry, and the low level select. Okay, that is going to be A and D. And then finally, manual override. So you want to be able to bypass the controls. Okay, so that's per typical for most processes. Manual override is on, and that's simply C. Okay, so there's the condition. I'm just going to call that X. You call it J, X, whatever, Z, whatever you want to call it. I'm going to call it X for this discussion. That the motor should run if A and D is high, or B ended with D naught is, or C. So any one of those conditions is true, the motor should run. The final condition, and let's use this color. Okay, is the shut-off switch. Maybe you have some maintenance or something to do, and you want to make sure that you can disable the system. So normally the shut-off switch is going to be deactivated. So what this says, it says, if actually a color pen here, sorry, let's go with blue, that the shut-off switch 1 is on, or 1 when activated. So therefore, this whole statement, any one of these terms can be true, right? But we also want E, the safety shut-off switch, to be deactivated, and that's going to be E naught. So when the safety is engaged, it's E. When it's not engaged, it's E naught. So there's the final expression for the output. And then finally, the output. Okay, again, we could connect this to a motor starter coil. Not directly, we need some interface circuitry, but we're not worrying about that for now. It's going to simulate with an LED, and the LED is to be illuminated when the pump is running. Okay, all right. Okay, so here's the actual circuit. So you're going to have to reproduce this for your schematic diagram. Be sure to include the pin numbers. Okay, remember, if your drawing is not complete or the pin numbers are missing, your drawing will be rejected by your professor. Okay, so if you go, and I'm going to write on all the terms here. So this is going to be B, and I find this actually very helpful to record it just like that. That would be B ended with D naught. Okay, so that's that term right there. And this is going to be right here is going to be A ended with D, and that would be that term right there. Okay, and this point is going to be A ended with D, ORed with B, D naught, right? And that's going to be sort of like that. Okay, and then right here, then this will be, it's getting kind of messy, sorry, be kind of ORed with C. Okay, so this is X right there. So that's the equation. Yeah, it didn't turn out very good, did it? Yeah. A little different writing on the iPad. Like that. Okay. So that equation applies to there. Okay. What this is for, and I want a different pen color. This is here, right here. This is to drive the LED. Because remember, one of the conditions was that the LED is turned on, okay, equals pump on or running or energized. Okay, so we just invert the logic level. Remember, this has to be current syncing to stay within the current parameters of the gates. So when this is going to be a logic 1, when the pump is supposed to be running, that will force a 0 here. This will forward bias the LED, and the LED will be nicely illuminated. Okay? All right, so go and erase that. Erase that. Now we're going to change the condition here. Okay, we're going to go to different color. Well, let's go with purple, something different. When the pump is off, that's going to be a logic 0. That's going to be a logic 1. Right? We have 5 volts here, so the LED is reverse biased, and therefore it is turned off. Okay, got it. Okay, so this is the truth table. This is what your professor is going to be evaluating in the lab. Okay, make sure it works the first time. Okay, or else you might lose marks. This is point X on the drawing, and if you want to connect that, to the logic monitor, yeah, then you're welcome to do so. And but this is what's actually we're going to be looking at. Okay, so before you call your professor over, make sure you tested it and make sure it all works. Okay. Now, if it doesn't work, then you're going to have to take a logic monitor, and we already went over some troubleshooting hints in class, and start poking around the circuit, cycle through the table, and figure out where it works, where it works and where it doesn't work. Okay. Maybe it's a faulty wire, maybe it's bad gate or something, I don't know. Okay, most of the problems in this lab are almost 95% are wiring errors. So, but as a technician, it's going to be your job to figure out where it went wrong. Okay, don't just put your hand up and say, sir, it doesn't work. Okay, we'll kind of guide you and tell you do this, but you need to learn to figure it out on your own and to step through it logically, step by step. Okay, it's all basic stuff. It's not that hard. Don't panic. Okay, if you go back into the description, you'll find that we asked you to, and this is just for consistency when we're testing, that your switch A will be your MSB, and switch B will be your LSB. Oh, there's a little tab here. It's not letting me. Yeah, it's not letting me grab it here. Sorry, this is a tab in the program that's not letting me select to put it where I want to. So anyway, there it is. Okay, so it's consistent. So when you're looking at the trainer, there's more switches than you need, but the leftmost switch that you're using, that must be your MSB, and that must be A. So this whole table assumes that E is low, so the safety switch is disengaged. Okay, and if we set E is equal to 1, we activate the safety, then the pump should be off. And that's sort of a roundabout way of checking our results without going through a 5-bit table. All right, so I hope this was helpful to you, and spend some time going through this to make sure you're clear. This isn't the first time you're going to be seeing this. You'll eventually be seeing word problems in both theory and lab tests, and we'll be doing lots more in lab and lecture. But there you go. Okay, so for homework, I would like you to construct a complete truth table showing all the individual steps. And what I mean by that is just like we've done in class, right? Other examples, plot all these in the columns to make sure that, I mean, this would be a fair test question. If I were to give you this circuit, I would fully expect you to be able to come up with, these two columns, in like 10 minutes or so. Make sure you're going through these, and that you know how to do it. Don't squander the opportunity. Okay. Okay. Once again, thanks for stopping by, and we'll catch you again. Cheers. Bye.